All right. Got it. Number one. How many electrons fit in the first energy level? 2, second, 8, third, 18, and fourth, 32. And you don't even have to memorize that. All you have to do is go to the periodic table, which I have somewhere. Just take a look at the noble gases. First energy level can hold up to 2. Second can hold up to 8. Third can hold up to 18. The fourth can hold up to 32. Now it says, hey, wait, that's only the second energy level. But if there's a dash in front, that means that there's 2-8 in front of it. So if there's a dash in front, that means the configuration is really 2-8, -18, -32, and so on. So you can use your periodic table to figure out how many electrons can fit in each energy level. Okay, that's question number one. Question number two. How do you tell how many electrons there are in an atom? It's the same as the number of protons. Exactly. Because protons are positive, you have to have an equal number of negative electrons to make a neutral atom. So 3 protons means 3 electrons. Also, if you take a look at element number 3 on the periodic table, you'll notice that its configuration is 2-1, a total of 3 electrons. Okay, number 3. As a result of the gold foil experiment, it was concluded that, if you remember a guy named Ernest Rutherford, took alpha particles, shot them at gold foil. Most of the alpha particles went right through the gold foil, indicating the atom's mostly empty space. That's not one of the choices. About 1 in every 20,000 bounced off, indicating that there was something really small in the middle of it that has to be really dense so the alpha particle bounces off of it. And because alpha particles are positive, whatever was in the middle also had to be positive because they repelled each other, they bounced off. So there you go, small dense nucleus choice 2. Number 4, the distribution of charge in an atom. Well, where is all the positive charge located in an atom?
The nucleus.
In the nucleus. So the nucleus is positively charged, and what surrounds it? Negatively charged electrons. Choice 3. Now, if you chose, let's say, well, actually, there's no other choice here that really works. Never mind. Okay, 5. Here's a pen. It's held above the table. This is position 1. This is position 2. Where does it have more potential energy?
Position 2.
Position 2. Why?
Because it has a greater distance.
Right, it's a greater distance from the source of gravity, which means when it falls, it has more energy to lose. The further away an electron is from the nucleus, exactly the same deal. This is why when you give an atom energy, electrons rise in energy levels, because now they have more energy. And when the electrons fall back down, they lose their energy in the form of what?
Photons.
Photons of light, exactly. Okay? So when you're asked which atom in the ground state has an outermost electron with the most energy, cesium, potassium, lithium, or sodium, they're all in group 1, that only has 2 energy levels. 3, 4, 5, 6 energy levels. That electron there in that last energy level is going to have the most amount of energy.
Wow.
Because it's furthest from the nucleus.
Indubitably.
Number 6. Alpha particles. Actually, you don't even have to guess. All you have to do is just look it up on reference table. Oh my gosh, there it is. So an alpha particle has a mass of 4. Beta particle doesn't really seem to have any mass at all, although you know better. It's 1/1836 of an AMU.
Yeah, of course.
And then a neutron has a mass of 1, and so does a proton. 7. The elements in group 2 are classified as. Now, these are the only 4 kinds of elements there are. You got metals, metalloids, nonmetals, and noble gases in that order. So we take a look at this. We got the zigzaggy line over here. The stuff on this side, these guys are all what? Including the elements in group 2. Group 2 is all on the metal side.
I am dumb too.
No, you're not. The nonmetals are the ones over here, and what are these puppies here along the zigzag? Metalloids, except for dog food, Alpo. Those guys are both metals. And over here, these guys are the what? Noble gases. All right. Number 8. How do you know which elements are going to have similar chemical properties? They're in the same vertical column. For example, oxygen, sulfur, and selenium. They all have 6 valence electrons. They form ion charges of -2. They're all in the same group, therefore they share the same chemical properties. Well, not the same exactly, but similar.
Yes, sir.
Yeah. 9! That the top number is the mass number and the bottom number is the atomic number. Give yourselves a hand. Woo!
Oh,
Can you keep the collective ah in the video?
Sure.
And throw it to everybody.
Number 10. You can actually do a process of elimination here. Or you could shine a flashlight on it and be a process of illumination. Anyway,
Yeah.
all right.
Right.
It says which pair represents two forms of an element in the same phase. That knocks out choice 1. These guys are in different phases,
choice
even
4.
though they're the same element. Choice 2, two forms of an element in the same phase. Okay, so far so good, but with different structures. Well, these guys have no choice but to have different structures. They have different numbers of atoms. It's choice 2, the allotropes of each other. Choice 3 aren't even the same elements, so you can eliminate that. And choice 4, you have a substance that's in 2 different phases, but this says elements. These guys are compounds, not elements.
They're not in the same phase.
And well, yeah, exactly, they're not in the same phase. So the correct answer was which one?
Number 2.
Number 11. Now, back when Dmitri Mendeleev first put together this epic periodic table, he based his order on atomic mass because that's all they knew. But he knew enough that to say, well, iodine's mass is less than the element next to it, but iodine needs to go in the same vertical column as fluorine and chlorine and bromine because it shares similar chemical properties. And when they discovered protons, they realized, hey, he's right, it goes in order of atomic number. So atomic number is how we order the elements on the periodic table. Number 2, 12. And, wow, really? Cn is zinc and O is oxide, zinc oxide.
Yeah. You got it wrong.
There's really nothing else it could be.
You really think you could
I don't think you
Yeah, I
can.
know. I meant like.
Hydroxide would be OH, oxalate's a polyatomic ion, and so is zinc peroxide. That is ZnO2 would be zinc peroxide, but I digress. 13. You can eliminate 3 of the choices immediately because they don't bond with anything. What 3 of these elements don't bond with anything?
Neon, radon,
The noble gases, neon, radon, and helium, already have their stable octet. They don't need to bond with anything.
Why did I?
Hydrogen only has 1 valence electron, which it can share with another atom. 14. An ionic bond. All right, here's how it works. Choice 1, equally shared. What kind of bond is that?
Covalent.
What kind of covalent?
Polar.
No.
Non-polar.
Non-polar covalent. Even sharing means that you're going to end up with no poles. Unequally shared by 2 atoms. What would that be?
Polar covalent.
Polar covalent. Transferred from the nucleus of 1 atom to the nucleus of another atom. What's
There
that?
are no such
That doesn't even make
electrons.
sense.
Right, electrons are not even
That was just-
found in the nucleus, so we can eliminate that choice.
So I'm gonna say it's 4.
Choice 4, transferred from the valence energy level of 1 atom to the valence energy level. Kaboom, kaboom. Metals lose electrons, become positive. Non-metals gain electrons, become negative. The opposite charges fall in love, and you get an ionic party? Bonding.
How did I get this wrong? How did I get the next one wrong? I don't.
15 has a definite shape and volume. Right, all solids have a definite shape, and they take up a definite amount of space. Number 16. Do you remember when we did PE diagrams? I'm so confused. Anyway,
So confused.
in a potential energy
Story of my
diagram,
life.
give me a piece of paper.
Here's my Regent. Just do it.
You do that for me?
I would do anything for you.
Wait, what?
Whoa!
Would you like give me half your paycheck for the rest of your life?
Ow.
Depends how much I make. If
Fair
it's
enough.
If it's like 6 figures, of course, but no.
6 figures? What if the 6 figures are all 0?
What if those figures were
6
8?
significant figures.
Oh!
Got him!
What if those
Okay,
figures
that's
were
gotta go in there
8s?
too.
Edit. That was a good joke. Look at it.
All right, when you're taking a look at potential energy versus time, do you remember in the PE diagram, you always go up first by adding activation energy, and then you go down. Well, what's really happening here is, well, first of all, this is the heat of the what?
Reaction.
Reactants, right? And this
Straight line.
down here is the heat of the products. Okay. You've got to add energy to break bonds. It takes energy to break bonds, and the activation energy is how much energy it takes to break a bond. And what is this?
It's a pop.
It's one of these little poppers, right? Now, I did some research to figure out how these things work. What they are little tiny pebbles that have been coated with a chemical called silver fulminate. Now, silver fulminate packs a lot of energy in its chemical bonds. And all you need is a little bit of an activation energy in order to get this thing to go. If I just drop it from here, though, it's not enough.
That's the bomb.
The reason
I suppose.
The reason why it's coated on rocks is because when you throw it, the rocks hit together, exactly, and the friction generates enough heat to set off the explosion. No,
Why not?
because the pebbles might fly and hit you in the eye, and then you would die, and I don't want that to happen.
In the back.
The pebbles would fly and hit you in the eye, and then you would die, and then I would cry, and I'm not going to have that. My point is this, guys. When you break a chemical bond, it requires you to absorb energy. A bond will not break unless energy is absorbed. So if the upside of the curve is breaking bonds, that means the downside of the curve must be
Making bonds?
making bonds.
Making bonds.
Okay? So it requires energy to be absorbed to break bonds, and then energy is released when new bonds are formed. If you think about it along the lines of a PE diagram, it'll be a little easier to remember.
Calm down.
To break a bond, energy is absorbed. 17. You've got a container that's got a certain volume at a certain temperature and pressure. An ideal container contains a different gas under the same conditions. Equal volumes of different gas, if they have the same T and P, will have the same number of molecules of gas in each, you see? And you might say, but wait, it doesn't say molecules. It says just helium and neon. Yeah, but remember that these guys being noble gases are monatomic molecules. One atom is a molecule. So your answer is choice 1, the same number of atoms.
That's like math.
It's kind of like math. 18. That phase changes are physical changes, and a crushing, of course, is still salt. Glucose and oxygen produce carbon dioxide and water vapor. You start with 2 substances, end with 2 completely different substances. That's your chemical change. Sweet. 19. Gas is made of molecules that are far apart and small. They don't lose their energy when they hit container walls. They travel in a straight line, no changing from their course. They move faster when it's hotter. They have no attractive force. Choice 2, they travel in a straight line.
Okay.
Yep. What phase would choice 1 describe? Solid, right, regular geometric pattern.
Solid squid.
Gas particles separated by very small distances. What would that be? Liquid.
Oh,
What do you mean? What do they mean relative to, that, to their size?
Well, like in a gas molecule, here's the size of one gas molecule. The next gas molecule is going to be like over here. Probably even farther than that. Their distances are very far apart when compared to how big the molecules themselves are. In liquids, though, if that's a molecule of liquid, the next molecule of liquid is here. So they're separated by very small distances compared to how big each molecule is. And of course, gas particles strongly attracted to each other, of course you know, they have no attractive force. Rock me Avogadro, etc., etc. 20.
Gas bonds.
Substances are pure matter. In other words, they're not mixed in with anything else. The only things that are classified as substances are elements and compounds. NH3, which is ammonia, is a compound. Air is a mixture of nitrogen and oxygen and argon, carbon dioxide, water vapor, methane, you know, all these different gases. It's a mixture, not a pure substance. Milk, of course, is not a substance either. It's made of mostly water, but it also has milk fat, and it also has proteins and
cow juice.
And cow juice, fresh cow squeezins. and maybe some cow pus and stuff like that.
I'm not drinking milk.
No, I mean, no, because the automatic cow milkers, they put it on the cows. If there's a sore on the cow's udder, then it'll actually squeeze the pus out. Don't worry about it. It's been pasteurized. It's been heat treated. It's antibacterial. It's dead.
It
doesn't matter.
Like
still
cows cattle.
Yes.
That's disgusting.
So you really are getting cow juice in the most insane way. Seawater, of course, is not pure Because it
Fish.
consists of
Fish.
like fish pee and water
Fish.
and salts and stuff like that.
Sharks.
So ammonia is the only pure substance here because it's a
And
compound.
Nemo.
And Nemo, of course. Number 21. Where do you get the information for 21?
Table S.
Table S. So, looking at all of these, the lowest electronegativity value would go to francium.
Well, thank you.
Has the lowest value of all of them. Which one's got the highest electronegativity value?
Fluorine.
Right, fluorine's the bad boy of the periodic table. 4.0, you don't want to mess with it. 22. I skipped 22. How horribly foul will it be? Why does water boil at a higher temperature than CH4? Well, let's take a look at the structures of these molecules. First of all, CH4.
What?
CH4 looks like that. H2O looks like that. What's different about their structures besides just their shapes?
That H2O is a
H2O is a polar molecule,
and it's bent.
and it's also a bent shape. What about CH4? Nonpolar. All right, now what that means is that this undergoes London dispersion force attraction, very weak attractive forces, where water has H on one side and O or F on the other.
Hydrogen bonds.
Hydrogen bonds! Hydrogen bonds! Hydrogen bonds! Hydrogen bonds!
Bonding.
See what I did there?
Yeah.
Here's how you can eliminate some of the choices. CH4 is made entirely of nonmetals, so it's covalently bonded. H2O is also made of nonmetals, it's also covalently bonded. So covalent bonding can't be the answer because they both have covalent bonding. It can't be ionic bonding because ionic bonding is only between a metal and a nonmetal, and there ain't no metals here. And metallic bonding is just between metals, and again, there ain't no metals here. So the only choice that you can have is choice 3. 23. You did this in the lab when you took sand and salt. It was a mixture, it was already pre-made. You put it in a beaker, you added water to it and stirred. Poured it off. Added more water to it and stirred. Poured it off. Added more water and stirred, so that by the time you were done, the only thing that was left of the sand and salt mixture was the...
Oh, I got this. Hold on. Hold on. I don't know.
sand.
It's
Oh.
number 4.
Why was the sand the only thing left? What did the water do?
It evaporated.
It dissolved the salt. And then you just poured it away.
I heard of that phrase. Stop talking.
So the reason why you can separate salt is because the water dissolves salt, but not sand. If sand was soluble in water, then all the beaches on the planet would have dissolved many eons ago. Eons is a good word. If you take the word eons and rearrange it, you get nose. Just a strange fact. 24! That nature is lazy and
Random.
messy. Lower energy and higher messiness. Entropy. Choice 2.
I was right.
Yeah. 25. Orbital, which is defined as a region around the nucleus in which an electron is most likely to be found, or the most probable location of an electron around the nucleus. Kaboom! Electron is where you find, orbital is where you find electrons. Where do you find protons and neutrons?
Nucleus.
The nucleus.
Obviously.
Positrons aren't even part of an atom. 26. Reference table R, which says organic functional groups,
I got this one right.
which oddly enough is the answer to the question.
Yes.
27. Take a look at group 17 on the periodic table, and you will find elements like fluorine, chlorine, bromine, and iodine. Take a look on reference table R, and you will notice a type of compound that contains fluorine, chlorine, bromine, or iodine, and we call them halides. So halides are what contain at least one element from group 17. 28. What is the total number of pairs of electrons shared between the atoms? Let's have a look. Let's draw a propanal. Prop is 3 carbons. An aldehyde is a double bonded oxygen on the end carbon, and the rest of these are hydrogens. Now the question says, how many pairs of electrons are shared between them?
Pairs. Oh.
Each bond is a pair of electrons. So 2 pairs of electrons is what gives you a double bond. So if you chose choice 4, you read it as how many electrons are being shared.
This is true.
2 pairs, 4 electrons. Number 29. You start at the anode, electrons are lost there, and go through the wire, and through the load on fire. They enter the cathode, and produce the salt ion. But, and the anions go through the salt bridge back to where? Where? You start at the anode, electrons are lost there, and go through the wire, and the song is getting tired. 30. Acids have a hydrogen, hydroxide for a base. Choice 3. 31. It's like totally on the periodic table. Like you look at germanium, which is Ge, and it's like got 4 electrons in its valence energy level. So like it's got a total of 4 valence electrons. Like choice 4, totally. 32. Excited state configuration atom. Well, let's take a look at it. As long as we were calcium 2882. Blah blah. Oh look, 2882. That's the configuration. Oh, but that's the ground state. The question's asking for the excited state.
So it's
Sodium. Sodium ground state configuration 281. This has 282. Hey, oh, but sodium only has 11 electrons. This has 12.
Oh no. It's not good.
Number 3. Potassium. 2683. Well, potassium, according to this, is 2881. Wait. Let's see.
Wait.
That's 19 electrons, 2881. How many electrons is this? Well, 2 plus 6 is 8, 8 plus 8 is 16, and 16 plus 3 is 19. Boom! There you go. And again, 2-8 for fluorine. Fluorine is actually 2-7 ground state, so that's too many electrons. 33. Which type of reactions are represented by this? Well, here, chlorine replaces bromine in a nice single replacement reaction. And here, sodium chloride is being decomposed into sodium and chlorine. Single replacement and decomposition. Choice 1. Hey, what would it be called if the sodium and the chlorine combined to form sodium chloride?
Synthesis.
Right. So that's not what we have here. 34. You've got a charge of +7 in the nucleus and -10 around outside. Overall, the charge is -3 because there's 3 more negatives than there are positives. 35. I'm going to run for president.
I know for you.
No, I'm going to run for
Precedent?
president. I'm going to run for
Will
president.
you set an example for future clause?
Exactly. 35. Here's the differences between the different kinds of bonds. A nonpolar covalent bond is when you have 2 atoms of the same element and therefore no difference in electronegativity. That would be a nonpolar covalent bond. A polar covalent bond is when you have 2 different nonmetal atoms bonded together, having different electronegativities. Both 2 and 4 have polar covalent bonds. Choice 3, an ionic bond, is when a positive ion and a negative ion attract to each other. Your nonpolar covalent bond is choice 1. 36. What does kilo mean? 1,000. So that's 50,000 joules.
This guy.
Choice 4. Oh. 37. Well, there's absolutely no way you can know the answer to this, which means you've got to look it up on one of the reference tables, specifically reference table I, which gives you the heat. Now, if you take a look down here, it says that a minus sign indicates an exothermic reaction. So we're looking for which one is formed by an exothermic reaction. Let's see, C2H4. C2H4's heat of formation is positive. That's endothermic. So it's not choice 1. Choice 2, HI, hi!
Hello.
That's also got a positive heat. Nope, that's endothermic. H2O gas. Well, we have 2 H2Os, but only 1 gas, and oh, looky, looky, looky. Negative. And a minus sign indicates an exothermic reaction.
This one got it right.
And just for fun, NO2 gas, no. NO2 gas, again, positive delta H, endothermic. Choice 3 is your only option. 38. Again, this answer is impossible to know unless you look it up on the reference tables. Reference table H. has the vapor pressure table. The question asks vapor pressure, so you want a table with vapor pressure. Let's see, ethanol at 80 kilopascals. So let's see. 80 kilopascals is here. The ethanol line is this line here. Drop it down, and you've got 73 kilopascals, because each of these represents 5. Number 39. What formula did you use to figure this out? Mava equals muvvub. In fact, not Mava equals muvvub. I can't believe I agreed with that. Mava equals muvvub requires you have a molarity of an acid and a volume of an acid. Where's the acid?
P1, B1.
P1, B1 over T1 equals P2, B2 over T2. Now, you actually only need P1, V1 equals P2, V2 because the temperature is held constant. If you do this, what's the answer? What was the answer for this one?
4.
Choice 4. Now, I'm not going to show you how. If you're one of those two people, I challenge you, try to figure it out on your own. Set up P1, V1 equals P2, V2, and try to work it through. Okay, 40. A 2,400 gram sample of an aqueous solution contains 0.0212 grams of NH3. What is the concentration of NH3 expressed as parts per million? Oh my gosh, I don't remember how to do parts per million. I better look up how to do it on reference table T. Parts per million is equal to mass of solute divided by mass of solution times a million. Well, there's your mass of solute divided by there's your mass of solvent, or solution rather, times a million. What'd you get as an answer?
5.0.
Choice 1. Exactly. 41. How do you know if it undergoes an increase in disorder?
Solid to
It goes
gas.
up in phase, right? Solid to liquid to gas. Well, you can stop at choice 1 because it goes from solid to gas. That's going to be an increase in disorder. Nice crystal lattice to completely messy gas. 42. Now I want you to remember something. Water has intermolecular attractive forces. If you want to freeze water, you have to get the water molecules close enough together and moving slow enough that their intermolecular attractive forces take over and the liquid molecules come together to make a solid. If you put something in water, that's going to make it harder for the water molecules to come together, which means you're going to need to cool it down more. The freezing point decreases. It makes it harder for water to freeze. Wow, that's really far down. In order to get water to boil, you have to break the attractive forces that water molecules have for each other. You heat it up to 100 degrees, that's enough to get the water to start boiling. But if the water molecules are being held onto by ions, not only do you have to break the attraction between the water molecules, you also have to break the attraction to the ions. That requires you to add more heat than you normally would have to break those attractions, making water's boiling point increase. And the more stuff you put in, the wider the range of liquid water is going to have. Higher boiling point, lower freezing point. Your answer for this is choice 3. That's why antifreeze is used. Antifreeze makes it harder for water to both boil and freeze. Keeps water a liquid for a greater range of temperatures. Number 43. You can actually eliminate a couple of choices right off because it says, for example, reduction. Well, aluminum goes from 0 to +3. That's going up in charge. That's oxidation. Wah! Al plus 3 gains 3 electrons to make Al0. That's absolutely true. But we're not starting with Al plus 3. We're starting with Al0. Wah! The half reaction has to agree with the overall reaction. Copper goes from 0 to +2. +2 electrons. Well, that's correctly written, but copper doesn't start off as 0. It starts off as +2. Wah! And number 4, copper starts off as +2 and ends up as 0. So far, so good. And you have to gain 2 electrons to get there. That's absolutely right. Choice 4, boom. 44. If each interval is if each interval on the axis labeled potential energy represents 10 kilojoules per mole. So, 0, 10, 20, 30, 40, 50, 60, 70. The heat of reaction. Well, if you put 20, that's the heat of reactants, not the heat of reaction. This was another one on your vocabulary review. Heat of reaction is the total change from start to finish also known as delta H, of energy in your reaction. If you start at 20, you end up at 50, that means you went up by 30. Choice 3, positive 30. 45, that you are at equilibrium, which is defined as equal rate of change in two directions. The rate of dissolving equals the rate of crystallization, therefore it's at equilibrium. 46, if you answered choice 4, choice 4 would be correct if the question was a substitution reaction. Choice 4 is not a substitution reaction.
Yeah.
If you chose choice 3, you almost got it right, but you forgot to break the double bond. In addition, the double bond has to break, and that's what gives you places for the chlorines to add. Let's draw it out. Ethene. There's ethene. We react it with chlorine, and the double bond breaks.
It's mathematical.
The breaking of the double bond gives you an extra place to put each of the two chlorines. That's why it's called addition. When the bond breaks, the chlorines will add. If you keep the double bond there, then that's really bad.
Tell me that's improv. Tell me that's improv.
Totally improv.
God, he's so cool.
I know. I'm like the Wayne Brady of Washingtonville. 47. Based on reference table J, which two reactants react spontaneously? If you take a look at reference table J, if you recall, and if you got it wrong, you might not have, the metals that are higher up undergo oxidation. The ones that are lower down undergo reduction. So if we take a look at each of these choices, magnesium is oxidized by zinc ions. Does that work? Magnesium is higher than zinc, so that one works. Now the reason why the others don't, copper oxidized by iron ions, copper is underneath iron, so copper can't be oxidized by iron. We take a look at lead and zinc ions, lead is underneath zinc, so lead cannot be oxidized by zinc ions. And finally, cobalt and sodium ions, sodium is way more active than cobalt, so there's no way that cobalt can be oxidized by sodium. It's just like that lab that you guys did where you took the different metals and you put the solutions over them to see which ones reacted. Okay, the ones that are higher up are the ones that are going to oxidize. Word. 48. Every time you change the pH value, you change the concentration of either hydronium or hydroxide, depending on which way you're going, tenfold. Tenfold. Now, if you're going from 2 to 1, are you getting it stronger as an acid or weaker as an acid? Stronger. And hydronium is what you get when you put an acid in water. So a pH of 1 is 10 times stronger than a pH of 2. 49. Where hydrogen is built into helium at a temperature of millions of degrees. That makes it fusion. Now, E equals mc squared says that during a nuclear reaction, a tiny bit of mass is converted into a monstrous amount of energy. Choice 3. Mass is converted into energy.
One more, let's go.
And the final question. 50. According to one acid-base theory, now they don't think you're smart enough to remember the names Bronsted and Lowry or Brunstead and Lowry. The reactant that donates an H+, well, look at NH3. NH3 becomes NH4. Does it gain an H or does it lose an H? That makes it the base. H2O becomes OH-. Did it gain an H or lose an H? It loses an H. H2O is the donor of the hydrogen in the forward reaction. You can eliminate choice 3 and 4 immediately because they use the word forward reaction.
I put 1 too.
Choice 1 would be the proton acceptor because it gains the H.
I think I just can't read.
So next time you donate something to somebody, does that mean you're going to take it from them?
Oh no!